Network analysis or electrical circuits. So few of you might have studied this subject in the name of network analysis, that is nothing but NA, and few of you might study this subject in the name of electrical circuits and network. So the interconnection of two or more circuit elements is called an electrical network. If a network contains at least one closed path, it is called electrical circuit. That is a battery connected to a bulb. Okay. This is called network, where this is a battery and this is a lamp. If the same battery connected with the lamp and closed path is there, then this is called circuit. Simple difference is, if it is a closed circuit, then it is an electrical circuit. If it is not closed, then it is known as a network. Studying or understanding the existing network is known as network analysis. Network or a circuit consisting of elements that are source and load or sink and interconnection. And interconnection is done with the wires, whereas sources are voltage, current, a battery or a generator. Load and sinks are, you can take lamps, motors, R, L, C parameters. Voltage. When you consider an atom having a nucleus is having a positive charge, and the orbit electrons will be there. This will be having negative charge. Since both the charges are in opposite, there will be a force of attraction between these two. If you want to move the charges, to overcome the force of attraction between these two charges, you need to do some work and you need to spend some energy. Each charges will be having some potential energy since they are separated by some distance. Difference in the potential energy is known as potential difference. And in electrical terminology, potential difference is known as voltage. And voltage is represented by the letter capital V or small v. And this voltage is given by work per charge, that is W by Q. And for this, units are joules, and for this, units are coulombs. And for voltage, units are volts. Small v equals to dW by dQ, where this is small change in the work or in the energy, and this is small change in the charge. For example, if you are having 100 joules of energy available for every 25 coulombs of charge, then the voltage or the potential difference is given by 100 by 25, which equals to 4 volts. If you consider semiconductive or conductive materials, there are free electrons available in the semiconductor or conductive materials. Semi or conductor. So if you observe a wire, there are some free electrons available. These free electrons moves at a random in all the directions within the structure in the absence of an external pressure or voltage. This is random, right? So if voltage or pressure is applied to this material, then all the electrons try to move in one direction, depending on the polarity of the voltage. This movement of electrons from one end of the material to other end constitutes an electrical current that is denoted by the letter capital I or small I. The electrons moving in these directions, let it be then the conventional current direction will be opposite, since electrons having the negative charge. Now current is defined as the rate of flow of electrons in a conductive or semiconductive material. It is measured by the number of electrons that flow past a point in unit time. Mathematically, it is represented as I equals to Q by T. For small charges, I equals to dQ by dt. Current is measured in amps. Suppose I am considering a 19 watts tube. 1 coulomb is the charge carried by 6.25 into 10 to the power of 18 electrons. A 19 watts tube with 230 volts, I equals to 0.0826 amps. This means the electricity is passing through the tube at the rate of 0.0826 coulombs every second. That means 0.5163 into the power of 18 electrons passing through the tube in every second, or simply the current is 0.0826 amps. Power and energy. Energy is the capacity for doing work. Power is the rate of change of energy, and it is denoted by the letter P. Then power is given by energy per time. That is nothing but W by T. For small powers, small p equals to dW by dt. Now, this we can write dW by dQ multiplied by dQ by dt. Multiplying and dividing with dQ, can get this dW by dQ. Work per the charge is nothing but a voltage, and dQ by dt, rate of change of charge, that is I. The units for power is watts. So by the definition, so 1 watt, the amount of power generated when 1 joule of energy is consumed in 1 second. If I am having 100 joules of energy and it is consumed in 4 seconds, then power is given by joules divided by 4 seconds. It is nothing but 25 watts.